How did we get here? How did a single species spread across every continent, outcompete other humans, and develop technologies unlike anything the world had ever seen? Well, for most of our existence, we scraped by like any other species. But over hundreds of thousands of years, we gradually progressed. We developed art, cultures, and advanced tools. We spread across the planet and transformed the world. This is not a story of sudden brilliance or manifest destiny. It is a story of countless small decisions that turned a tool-making ape into a civilization-building species. In this documentary, we'll explore the origin of our species, what made us different from the other hominins, and why we lived and they didn't. We'll follow the earliest breakthroughs in Africa, the invention of agriculture, and the conditions that gave birth to the first empires. This is a long and complex story, but by the end, you'll understand where we came from and how humanity went from stone tools to empires. No AI was used in the production of this video, and if you want to support humans, watch this all the way through. Now, let's jump right into the entire history of our species. The origin of our species is a complex topic that requires some context. We might as well start at the beginning of our genus. The genus Homo first appeared around 3 million years ago. We evolved from the smaller-bodied and brained Australopithecines. Our genus evolved to be larger with more robust molars. The oldest fossil of our genus is the 2.8 million-year-old mandible LD350-1. The specimen's anatomy strongly diverges from Australopithecines and is more closely aligned with Homo. We don't know much about who these hominins were, as the next oldest remains from our genus comes from 2.3 million years ago in the form of Homo habilis. Homo habilis is one of the most important species in our genus as they are the earliest species we have substantial remains from. By this time, they already had larger brains than their Australopithecine ancestors, over 20% larger in some individuals. With this brain, they were able to found the Oldowan tool tradition, a method of turning stone into usable tools. These tools may look quite simple to us, but they gave habilis a literal cutting edge. With this, they could shape wood into spears, butcher animal carcasses, and process edible plants. Though Australopithecines and even Paranthropus may have also used stone tools as far back as 3.3 million years ago, the Oldowan tradition that habilis invented was a turning point in human evolution. From now on, stone tools would be essential to our survival. A few 100,000 years later, the species Homo erectus appeared. This species was taller, more efficient at running, and had an even bigger brain, averaging about 150 cubic centimeters more than the brainiest Homo habilis and double the size of an Australopithecine. With their larger brain, they eventually developed the Acheulean tradition. Acheulean tools consisted of cores of stone worked on both sides to create a hand axe with much more cutting area than ever before. These tools were like the Swiss Army knives of their day, able to do everything from woodworking to butchering. With these new tools and a more athletic anatomy, Homo erectus was able to spread around the world, from Africa to Northern Europe all the way to China and Southeast Asia. For this reason, Homo erectus is one of the most significant members of our genus. The sons and daughters of erectus would adapt to their local environments and diversify into new forms. Generally speaking, these hominins now spread around the world and are considered Homo heidelbergensis. Homo heidelbergensis is a very important species and is ancestral to us but also Neandertals and Denisovans. For this reason, we should take a look into how these hominins lived, in order to understand what would come next. Homo heidelbergensis had larger brains than their erectus ancestors. Their brains range between 1100 to 1300 cubic centimeters, which is in the range of modern humans. This larger and rounder brain likely supported more complex social behavior, and certainly more complex tool-making. At the site of Schöningen in Germany, we have found nearly a dozen well-made spears. Many of them were weighted like javelins and likely thrown as projectiles. From other sites in Africa, we have even found well-made stone points that display evidence that they were hafted on the end of a spear. Their stone tools were much more sophisticated than ever before with well-made Acheulean-style hand axes, but also sharp-flake tools. Their ability to survive in very cold environments suggests that they may have crafted complex clothing from animal hides. Fire has also been found at many of their sites, and it is possible some populations were able to regularly create it. They hunted a large variety of animals, including some of the largest of their time such as horses, rhinos, and even elephants. Homo heidelbergensis may have not been as pioneering as Homo erectus, but they really settled into their new homelands and became the apex predators. They developed new technology, hunting techniques, and even culture. Being spread across such a diverse territory, fossil evidence shows that they were already diverging into new species. In Europe, they were shorter and squatter to endure the brutal winters, while in Africa they were slimmer, and in Asia they had their own unique adaptations. By around 400,000 years ago, the differences accumulated enough to consider these populations as different species. In Europe were the ancestors of the Neandertals, in Asia the ancestors of the Denisovans, and in Africa our ancestors. It is important to understand that the Neandertals and Denisovans are essentially cousin species to ourselves. We both descend from the same populations of Homo erectus, and all three species just became adapted to their own unique environments. And our species, just one strain of humanity, evolved in Africa. But what exactly makes us human? It's more than just the shape of our skulls. It's also our creativity, empathy, and social nature. Fossils don't tell us the whole story of the origin of our species. While the anatomy of humans in Africa slowly evolved into that of Homo sapiens, the behavior of hominins on this continent also gradually became more sophisticated. These actions hint at the development of new cognitive abilities and social dynamics, which define what it truly means to be human. The period when these mental capabilities started appearing is known as the Middle Stone Age, which lasted roughly from 300,000 to 40,000 years ago. During the Middle Stone Age, humans across Africa increasingly exhibited signs of thinking in terms of abstract concepts, planning strategically, innovating technology, and applying symbolic meanings to objects. Evidence of growing intelligence appeared in stone tools and other artifacts used by early Homo sapiens. To be clear, other hominin species, especially Neandertals, also displayed many of these novel behaviors. But the nature of these developments in Africa during the Middle Stone Age suggests that certain changes in the functioning of human brains might have been limited to our species. The earliest sign of these cognitive advances come from stone tools discovered in Africa. For millions of years, hominins had been striking rocks against each other to create sharp edges. But around 300,000 years ago, a technological transition was taking place. Stone tools were becoming smaller and more diverse. Archaeologists believe that these changes represent a fundamental shift in how humans crafted tools. Before the Middle Stone Age, archaic hominins held stones directly in their hands as they performed tasks. But this transition to smaller tools marks the point when humans began attaching stone flakes to handles. Firmly securing stone to a piece of wood or bone requires binding, like string or sinew, and adhesives like bitumen or plant resins. These hafted tools included knives, scrapers, and spears, and marked an increasing investment in technology. They took more time and brainpower to craft than older tools. People had to collect, prepare, and assemble multiple materials. But as a result, humans became more efficient and productive hunter-gatherers. Beyond their effectiveness, hafted tools were also more versatile than older implements. Since handles and stones could be arranged in various configurations, a range of tools became possible. In fact, innovative thinking intensified and people made stone flakes into an increasing variety of shapes. In particular, two new types appeared during the transition to the Middle Stone Age. One of them are known as blades, and they are defined as being twice as long as they are wide. The long edges of blades are roughly parallel, straight, and sharp, ideal for slicing. The adoption of this technology was slow, and blades remained rare for hundreds of thousands of years. But another key tool, points, became ubiquitous across Africa quite quickly. By 250,000 years ago, stone points were being used by humans in northern, eastern, and southern Africa. The classic point of the Middle Stone Age was roughly shaped like a triangle or a teardrop. They primarily served as the piercing, sharp end of hunting spears. Before this invention, hominids had made spears by sharpening the end of wooden poles. But by adding a stone point to a long shaft, humans became more lethal hunters. The weight and sharpness of the stone gave hunting weapons greater impact and penetration. In order to create more specialized tools, humans in Africa had to invent fundamentally new techniques for working stone, which reveals the extent to which their intelligence was increasing. Before the Middle Stone Age, toolmakers had used knapping, the process of striking one stone against another to remove flakes, until they were left with the shape they desired. But during this period of cognitive evolution, humans developed a novel method known as preparing a core. Cores are blocks from which a person creates a stone tool. Preparing the core refers to the process of shaping it by removing flakes according to a specific series of steps, before making a final strike to release the actual tool. Crucially, prepared cores allowed people to predetermine the shape of the tool. An expert stone knapper can use this method to produce points and blades, among other shapes. Preparing a core requires sophisticated memory and reasoning to predict the result of a sequence of events, not to mention extensive practice to master. The fact that this method spread across a continent around 300,000 years ago shows that humans were teaching each other complex crafts, a sign that social gatherings between neighboring groups of hunter-gatherers were common by this time. With the invention of prepared cores, knapping became a more precise skill. As a result, humans grew more concerned with finding and using the best types of rock. Evidence of this appears among the remains of their campsites. At the start of the Middle Stone Age, Africans increasingly collected fine-grained stones, such as obsidian and flint, whose microscopic crystalline structure makes them fracture easily and with remarkably sharp edges. Furthermore, they started carrying fine-grained stone with them for extended periods, often transporting it up to 180 miles or 300 kilometers. Some archaeologists have proposed that this represents the emergence of simple trade networks or gifting traditions within human societies. In addition to the creation of increasingly complex toolkits, humans adopted a new behavior at the start of the Middle Stone Age: the use of pigments. Most often in Africa, this involved a collection of red ochre, a type of soft, iron-rich stone that can be ground into a powder. Ochre powder has often been used to color other materials such as human skin, clothing, or used as paint. Some archaeologists argue that its use at several sites after 300,000 years ago strongly suggests that humans in Africa had begun to impart symbolic meanings to colors and markings. At one site in Sudan on the Nile River, people made ochre powder on heavy grinding stones 223,000 years ago. And in Zambia, around the same time, purple and red ochre were preferentially collected. The selection of specific colors shows up again in South Africa, 164,000 years ago, and strengthens the argument that ochre use was symbolic. If people were in fact using pigments to change the color of objects, this act reveals the evolution of new cognitive abilities. By coloring themselves or their possessions, early humans were consciously or subconsciously communicating something to others who saw them, such as their attractiveness, status, or tribal affiliation. The ability of social groups to use symbols to represent ideas, such as group identity, requires the capacity for abstract thought. The grinding of pigment powders, the crafting of hafted tools, and the mastery of prepared cores marked a turning point in the behavioral evolution of hominins. But this transition was not a fast process. Even though we mark the start of the Middle Stone Age at around 300,000 years ago, signs of these sophisticated behaviors came much earlier, and it took a long time for them to become commonplace. It took hundreds of thousands of years for modern behavior to become widespread among the hominins in Africa, suggesting that the evolution of the human brain was a slow process. It's important to note that during this transitional period, multiple hominin species lived in Africa, including early stages of Homo sapiens, late stages of Homo heidelbergensis, and the more distantly related Homo naledi. We can't currently associate specific species with specific types of stone tools, but so far, Middle Stone Age tools have only been found with Homo sapiens fossils. During the second half of the Middle Stone Age, a whole new set of behaviors appeared, leaving little doubt that Homo sapiens had reached a modern level of intelligence. Africans started forming strong cultural identities, continued to invent new types of tools, and began using new types of materials for symbolic purposes. The significance of these advances was profound, as they set the stage for the ultimate success of our species over all other hominins. Interestingly, intensifying cognitive evolution corresponded with a period of favorable climate in Africa. This was the last time Earth was as warm as it is today. Africa received lots of rain, which made its ecosystems more productive and life easier for humans. By this period, Homo sapiens was clearly the dominant hominin in Africa. Furthermore, studies of modern African DNA have shown that this period witnessed the origin of many genetic lineages that still survive to this day. In other words, large migrations of humans across the continent resulted in the separation of the ancestors of people living today in East, South, Central, and West Africa. It's during this period, the late Middle Stone Age, that cultures start to form in many parts of Africa. Cultures are communities of people who share a set of customs that differ from those of other communities, and their appearance hints at increasingly complex social relationships. For example, around 145,000 years ago, humans living in what is now Morocco began making stone tools with short, narrow stems protruding from their bases. These stems were probably inserted into holes at the end of wooden handles, an innovation for making more sturdy hafted tools. And importantly, stemmed points, blades, and scrapers were used by human groups living in northwest Africa and the Sahara Desert, but not in any other part of the continent. The spread of this custom defines an archaeological culture known today as the Aterian, and this shows that human behavior was increasingly being affected by that of their neighboring bands. Several other innovative regional traditions emerged during the Middle Stone Age. One fascinating case, known as the Lupem Ban, appeared in Central Africa, centered on the Congo Basin. Here, humans made heavy-duty stone axes, likely used for woodworking in an area often covered by forest. They also made stunning stone points. They were symmetrical, long, narrow, and thin. Lupem Ban points were remarkable demonstrations of stoneworking ability. They were probably used as both spear points and knives, and they were crafted using a technique known as bifacial knapping, meaning that they were shaped by removing small chips from the entire surface of both faces of the stone. Bifacial knapping had been experimented with by archaic hominins, but it was mainly for clunky hand axes, not thin, refined points. Interestingly, bifacial points of different shapes and sizes appeared in most parts of Africa after 120,000 years ago. For example, along the Rift Valley of East Africa, humans made versions that were only 3 to 5 centimeters long and shaped like leaves. Two other examples of regional stone traditions appeared along the Nile River. Here, some groups used a set of highly specific steps to prepare a core from which they produced a type of long triangular stone point. Known today as Nubian points, they became common spearheads around 88,000 years ago. At the same time, a distinct culture appeared to the south, along the upper Nile of Sudan. Referred to archaeologists as the Howiesons, these people preferred circular prepared cores and tools. It's likely that these two groups came into contact with each other but retained their own way of doing things, suggesting that tribal or ethnic identities existed by the end of the Middle Stone Age. The rise of regional traditions in Africa highlights another increasingly prominent aspect of modern behavior: the tendency to innovate. After 130,000 years ago, new types of tools kept popping up across the continent, and they took on increasingly standardized shapes. People started making end scrapers, which are blades whose end has been modified to perform scraping tasks. Another type of tool called burins by archaeologists appeared with the Howiesans culture. Burins are used as chisels to carve grooves into wood or bone. Howiesans and groups living at the southern tip of the continent also began making a strikingly small type of tool called a bladelet, which, as its name suggests, are tiny blades, usually less than 1 centimeter wide. Bladelets were likely used by mounting several together on a single handle. They epitomize trends in toolmaking that would continue after our species left Africa: the tendency toward miniaturization and increasing hafting complexity. Finally, during the late Middle Stone Age, humans started creating formalized implements from another type of material. Within the Aterian culture, these were shaped like knives and spatulas and probably used for smoothing animal hides. In South Africa, humans crafted cone-shaped points for arming hunting weapons, and they also made awls for poking holes in soft materials. Bone spatulas and awls were probably useful innovations for the production of clothing and bags from animal skins. But the most remarkable bone artifacts of the Middle Stone Age were discovered in the Democratic Republic of Congo, where several skillfully carved barbed points, likely used at the tips of fishing weapons, were made around 95,000 years ago. The emergence of specialized bone tools demonstrates the mental dexterity of our species at this stage. Bone had rarely, if ever, been used to make such sophisticated tools by archaic hominins. We were increasingly solving problems with novel approaches, and finding new applications for easily accessible resources. Not only was Homo sapiens becoming more intellectually flexible, but also more strategic. We can see this in the way they moved across the landscape and used resources. The nomadic movements of humans became more planned. Some groups established base camps from which they undertook forays to collect specific resources, such as high-quality toolstone. Hunter-gatherers also started ringing their campfires with rocks and used certain areas for specialized activities. The main hunting target tended to be large herbivores such as antelope. In some cases, Groups of hunters cooperated to conduct mass hunts and used landscape features to drive animals into choke points. But increasingly, humans in Africa incorporated other foods into their diet, including from aquatic environments. They collected shellfish from beaches and fished in rivers and lakes. They targeted smaller terrestrial animals such as jackals in Morocco and the tiny duiker antelope in the coastal forests of South Africa. Homo sapiens foragers were using their growing intelligence and novel tools to become generalists, capable of surviving in a wider range of habitats. During this same time period, we also see a rise in symbolism, and our social capabilities also contributed greatly to our success. But other signs of symbolic and ritual behavior come from this period. For example, the oldest known jewelry made by Homo sapiens comes from the Assyrian culture. They were beads made from seashells which could have been components of necklaces or bracelets. They've been discovered at 7 Moroccan sites and range from 142,000 to 75,000 years old. Furthermore, 2 sites in Israel with Homo sapiens fossils and seashell beads of similar age and slightly younger artifacts of this type come from 3 caves in South Africa and 1 in Kenya, meaning that across the African continent and into the Near East we were valuing jewelry. Another sign of decorative activities includes some of the oldest direct evidence for the production of paint. At Blombos Cave in South Africa, around 100,000 years ago, a person mixed ochre powder with a liquid, crushed bone, and charcoal in a large seashell. Whether this paint was used on human bodies or other objects, its use served as a form of communication and further demonstrates the ability for abstract thinking. The appearance of both jewelry and paint suggests that people were searching for shorthand ways of displaying their status and identity to others. Maybe they were encountering other bands of hunter-gatherers more frequently during this period, when favorable environmental conditions fostered population growth. Ritual behavior, another way of mediating social relationships, also emerged at this time. The oldest known burial of Homo sapiens took place in Israel 120,000 years ago. 2 other Middle Stone Age burials have been discovered in Kenya and South Africa. In Morocco, Assyrians built a pile of sandstone slabs, and in South Africa, people left behind crystals and other visually striking stones in the dark depths of caves. This creation of ritual sites, including graves, implies that Homo sapiens had developed spiritual beliefs by the late Middle Stone Age, another defining trait of our species. The apex of Middle Stone Age social complexity occurred near the end of this period at the southern tip of the continent. Between 73 and 59,000 years ago, 2 highly distinct cultures arose in South Africa, which combined many elements of modern human behavior, including some especially unique ones. The first of these is known as the Still Bay culture, and has been documented at 8 caves spread across more than 1,000 kilometers of coastline. The people of the Still Bay made seashell beads, bone points, round scrapers, and leaves shaped by facial stone points. These spear points represent a particular technical and aesthetic achievement. People of the Still Bay culture used colorful stones and maintained a highly symmetrical shape with 2 innovative techniques that gave them great precision. First, they heated silkrete, a type of stone, to enhance its suitability for flaking. And second, they performed the final touches using pressure flaking, which is the removal of tiny flakes by pressing a thin piece of antler against the stone. In addition to their functional role, these leaf-shaped points likely served as prestige items, reflecting a growing concern with social image. The people of the Still Bay were also unique for their production of art. They engraved and drew simple geometric designs on small pieces of stone. The most remarkable of these pieces contains a crosshatch design in between 2 parallel lines. It's considered by some experts to be the oldest undisputable art. Interestingly, similar crosshatch patterns were discovered among the debris of Still Bay camps, revealing a repeated motif that likely held some meaning to the prehistoric people who drew it. The Still Bay culture spread across a large area, suggesting that sophisticated methods of producing points were shared between many groups. Gatherings of multiple bands likely served as opportunity to teach crafts, gather information, and form relationships. Jewelry, art, and prestige spearheads hint at the mediation of interactions within this network with established social norms. The Still Bay culture marked the high point of human flourishing up until that point. While it demonstrated the potential of our species, it revealed the fragility of society at this time. The customs that defined this culture remained in use for around 2,000 years, but then they disappeared when a major population decline struck the region, showing just how quickly a culture like this can dissipate. Fascinatingly, about 5,000 years after this collapse, The region experienced a renaissance of social complexity, known today as the Howiesons Poort culture. It started around 65,000 years ago, with the proliferation of a new set of traditions, radically different from those of the Still Bay. Gone were the leaf-shaped points of their predecessors, replaced by tiny bladelets, some of which were modified into a standardized crescent shape. Toolmakers of the Howiesons Poort attached these crescents and bladelets to handles using glue made from a mixture of plant resin and ochre powder. Crescents were probably used as points or barbs on hunting weapons. Given their small size, some archaeologists theorized that crescents were arrowheads, which, if true, would make the people of the Howiesons Poort the oldest known inventors of the bow and arrow. In addition to innovative tools, they also developed their own unique style of art. Pieces of ostrich eggshell were engraved with various designs, including ladder-like patterns. Discovered at 3 archaeological sites, eggshell decorations of the Howiesons Poort exceeded the scale and complexity of the Still Bay drawings. Finally, these people mysteriously carved animal rib bones with regularly spaced notches. They could have been notational pieces or possibly musical instruments. The Howiesons Poort culture covered an even larger area than the Still Bay, and their technology and art reflect the renewal of strong social bonds. These two cultures are undeniable evidence that Homo sapiens with modern levels of intelligence lived in Africa more than 60,000 years ago. The remains they left behind resemble those of many hunter-gatherer societies from more recent periods. Innovative, highly social, and artistic, they were human in the full sense of that term. Ever use an AI app and think, that's not quite right? Well, that's exactly why companies like Aligner exist. AI doesn't magically get smarter on its own. Every leap in reasoning comes from real people testing it, correcting it, and pushing it further. And that's where Aligner steps in. They connect top thinkers with paid, flexible remote projects from leading AI labs. If you can out-reason today's models, whether that's in math, coding, finance, data analysis, or just sharp logical judgment, Aligner will pay you up to $150 an hour. But what does that actually look like? Well, you might review an AI's step-by-step math solution and point out where it went off the rails. You might grade whether a piece of code is correct or explain how to fix it. Or you might compare 2 answers and judge which one demonstrates better logic. It's real expert work that actually shapes how the next generation of AI thinks. So if you want to literally help build smarter AI and get paid for your brain, check out Aligner using the link below. Although the cognitive capacities of our species were notable, we need to acknowledge an important fact. Most of the behaviors displayed by Africans of the Middle Stone Age also apply to Europe and its hominin occupants. As Homo sapiens became more modern, Neandertals also used increasingly complex technology and demonstrated signs of social thinking. Between 250,000 and 40,000 years ago, they made hafted tools, used prepared cores, made ornaments, used pigments, and buried their dead. Their actions may have lacked a few traits seen in Africa, but it's hard to argue that Neanderthals had a dramatically inferior intelligence to ours based on the archaeological record. It's possible that there was a significant difference by the way our brains worked, and that difference led to our eventual global dominance. But it's hard to pinpoint that difference using the remains left behind at prehistoric camps. Instead, current archaeology reinforces the similarities between our two species. The impact of human evolution during the Middle Stone Age was tremendous. Homo sapiens became formidable. By inventing new tools, our ancestors foraged more efficiently from a wider range of ecosystems. Some anthropologists believe that the capacity for abstract thinking demonstrated during the Middle Stone Age implies the emergence of complex language, which may help to explain signs of strengthening social networks. Cooperation gave our species an evolutionary advantage. The ability to borrow technological ideas, share information about the location of food and water, and receive aid from neighbors set the stage for our spread into other continents. Given the importance of the Middle Stone Age, it's notable that prehistorians didn't recognize the innovative nature of this period until recently. For a long time, the subsequent Upper Paleolithic of Eurasia was viewed as more significant. Increases in the production of art and ornaments led to the idea of a human revolution around 45,000 years ago. It was thought that this was caused by a dramatic evolutionary change in the brain of Homo sapiens. But today, most archaeologists dismiss this idea and prefer a gradualist model. They propose that all of the mental capabilities that define this human revolution emerged over hundreds of thousands of years and were present well before the Upper Paleolithic. This was Africa's hidden revolution, the slow and sporadic appearance of modern human behavior. In fact, the word revolution no longer seems to be appropriate. During the Middle Stone Age, tens of thousands of years could pass with little technological change. When novel customs appeared, such as the use of jewelry or the napping of leaf-shaped points, they didn't necessarily remain permanent practices. Given the slow and irregular nature of behavioral change, experts are beginning to acknowledge that cognitive evolution was not the only factor influencing the archaeological record. Human actions were also influenced by environmental conditions and demographic factors. The number of Homo sapiens in Africa was likely quite small during the Middle Stone Age and subject to fluctuating climates. People probably didn't behave the same way when their populations were dwindling as when they were growing. In fact, increasing signs of modern behavior coincided with warm, wet conditions, when bands of hunter-gatherers likely lived at higher densities. This favored the formation of stronger social networks, the implementation of symbolic codes, and the emergence of regional cultural identities. The full expression of our humanity comes not only from the way our brains work, but also from interaction with other people. For most of the history of our species, we were African. The tall, rounded skulls that characterize Homo sapiens evolved there around 200,000 years ago. And for the next 140,000 years, humans with this anatomy were mostly restricted to that continent. Eurasia, on the other hand, was the domain of other hominins, with longer, lower craniums, including Neandertals in the west and Denisovans in the east. So the next major step in the prehistoric journey of our species would be the expansion out of Africa. The capacity for continent-wide dispersals was not unique to us. Multiple hominid species had migrated out from Africa throughout prehistory. Homo erectus first colonized Eurasia more than 1 million years ago, and Homo heidelbergensis did so 600,000 years ago. Africa was the birthplace of many hominins, and Eurasia was the recipient of these tool-wielding invasive species. When it comes to us, the exit from Africa was a complex story with several chapters. In fact, there's evidence that Homo sapiens made multiple separate incursions into Eurasia during the Middle Stone Age. Early movement out of Africa occurred between 210 and 80,000 years ago, but they were limited and temporary. The first group of Homo sapiens to leave Africa died out, leaving behind no living descendants. The final permanent expansion of Homo sapiens out of Africa would not begin until about 60,000 years ago. Despite the failure of early migrations, they demonstrate that our species' drive to expand has a deep history, but that the conditions necessary for our success occurred more recently. Evidence for early dispersals out of Africa comes primarily from Homo sapiens fossils discovered in Eurasia. Unsurprisingly, most of these have been found close to Africa. The oldest comes from Greece and is at least 210,000 years old. Found at Apodema Cave, there is disagreement among experts whether this partial skull belonged to that of early Homo sapiens or early Neanderthal. If it did in fact belong to a member of our species, it represents a surprisingly early movement into Europe, a continent thought to be primarily inhabited by Neandertals at this time. The idea that the Apodema skull belonged to Homo sapiens complements information obtained from Neanderthal genomes. Interestingly, portions of their DNA sequences seem to have originated from an extremely early interbreeding event with Homo sapiens, probably more than 200,000 years ago. So it's possible that the Apodema individual belonged to a population of early Homo sapiens that migrated into Europe and mated with Neandertals before disappearing. The next evidence for Homo sapiens outside of Africa comes from a cave in Israel called Mizlaya, where a jaw and teeth with traits of our species was discovered. This individual belonged to a group that used this cave several times around 152,000 years ago. They were cooking meat of deer, gazelle, and aurochs. They also made triangular-shaped tools from prepared cores. The presence of Homo sapiens in the Levant is not surprising. This region, the strip of land along the eastern Mediterranean coast, is adjacent to the Sinai Peninsula, which is the only land connection between Africa and Asia. The woodlands and permanent water sources of the Levant harbored an inviting environment for hunter-gatherers compared to the surrounding deserts. It was a natural place for pioneers to establish stable populations after walking out of Africa. About 30,000 years later, our species again left behind evidence of living outside of Africa. The renewed appearance of Homo sapiens in Southwest Asia is associated with a shift to warm, wet conditions, which may have made migrations out of Northeast Africa more feasible. Fossils from 2 sites in Israel and 1 in Arabia range from 120,000 to 90,000 years old. These discoveries paint a vivid picture of human societies thriving outside of Africa. At Sahul and Qafzeh Cave in Israel, remarkable signs of modern human anatomy and behavior were uncovered. Partial and complete skeletons of 26 people are unambiguously Homo sapiens. Several were intentionally buried. Furthermore, red ochre paint, seashell beads, and animal bones buried as grave goods reveal a rich array of ritual and symbolic customs. Comparatively, the Arabian fossil record is much more scarce. A single hand bone from a site called Al-Wusta has been identified as Homo sapiens. Living around 90,000 years ago in the northern Arabian desert, this Al-Wusta group of humans made camp near a lake, at a time when this region received more rainfall than it does today. Grassland supported large herbivores such as buffalo, hippo, elephants, and camels. In fact, prehistoric sites with stone tools from several humid phases exist across the Arabian Peninsula, suggesting that hominids of one species or another lived here. Homo sapiens could have reached the Arabian Peninsula via the Sinai Peninsula, or by crossing a narrow stretch of water 1,200 miles or 2,000 kilometers to the south, called the Bab el-Mandab Strait. Depending on the sea level of any given period, this strait could be only 2.4 miles or 4 kilometers wide. Standing across the coast of East Africa, humans could see the southwest tip of Arabia and may have traveled there on simple rafts. Regardless of the route taken to arrive there, Al-Wusta produced an especially interesting discovery. Humans at this camp primarily produced stone tools using a specific type of circular prepared core, a method that has also been documented at the Sahul and Quasi caves. The technical term used by archaeologists for this technique is the centripetal levalwa. Interestingly, centripetal levalwa might be a signature of this phase of Homo sapiens dispersal out of Africa. Across the Levant, Arabia, the Nile Valley, and East Africa, humans used this type of core during the late Middle Stone Age, suggesting that our species may have carried this custom with them as they migrated into Southwest Asia. This idea remains a hypothesis because other hominin species were also capable of using prepared cores. Neandertals in Europe and the Levant even used centripetal levalwa around the same time as Homo sapiens. This means we can't necessarily equate this type of core with the presence of our species. Some experts have proposed that the use of the same stone knapping techniques resulted from a cultural exchange between species that made contact in the Levant. Based on fossils from the Levant and Arabia, it's clear that between 120,000 and 90,000 years ago, Homo sapiens dispersed into Southwest Asia. But other discoveries might show that our species made it much further out of Africa during this period. In East Asia, hominids including Homo erectus and Denisovans had been living for hundreds of thousands of years. But at 8 sites in southern China, Laos, and Indonesia, Homo sapiens have been found in sediments dating between 130,000 and 60,000 years ago. If these findings are accurate, they suggest that the dispersal of humans did not stop in the Levant and Arabia but continued all the way through southern Asia. But not all archaeologists are convinced of this scenario because of questions surrounding the age of these East Asian fossils. Most are teeth or small fragments of bone, and their small size leaves open the possibility that they were buried in sediments that are older than their actual age. In fact, some human fossils from China have been shown to be much younger than initially reported. Therefore, experts aren't exactly sure what to make of these East Asian discoveries. Another line of evidence used to support an early dispersal across southern Asia comes from the Indian subcontinent. No hominin fossils more than 40,000 years old have been found here, but stone tools have. Interestingly, the centripetal levalwa and other prepared core techniques appeared in India and Pakistan between 100,000 and 80,000 years ago. While these tools are similar to those used in the Levant and Arabia by Homo sapiens, we can't rule out the possibility that either Neandertals or Denisovans were the ones making these tools in South Asia. Finally, one site in Australia with stone tools has been dated to 65,000 years ago. That's 15,000 years older than any other evidence of human activity on that continent. But like the fossils of East Asia, the age of these tools have been questioned by critical experts. Furthermore, the idea that Homo sapiens lived in Australia and East Asia more than 60,000 years ago runs into an issue when we examine our genetics. We will get into this topic in more detail later, but essentially, DNA sequences of modern and ancient peoples show no sign that they descend from humans who left Africa more than 60,000 years ago. This leaves only one explanation that can reconcile the current genetic data with early dates of Homo sapien fossils in East Asia. If our species lived in East Asia and Sahul between 120 and 70,000 years ago, these groups must have died out before a second wave of immigrants arrived from Africa. Interestingly, there is one event that could explain mass deaths of humans in East Asia around 74,000 years ago. The super eruption of the Toba volcano in Indonesia, the largest volcanic eruption of the past 2.5 million years. Toba released enormous amounts of gas and ash into the atmosphere and destroyed the ecosystems of surrounding islands. Aside from local devastation, it also impacted the wider climate. The Asian monsoon weakened immediately after the eruption, causing a decline in precipitation across South and East Asia. A popular theory argues that this climatic change was global and extreme and even impacted the humans living in Africa at this time. This idea comes from the fact that the Toba eruption occurred around the same time that ancestors of all living people went through a genetic bottleneck, meaning the size of the human population became smaller, possibly only around 1,200 people. So theoretically, the negative environmental impact of Toba may have made conditions for humans more difficult, causing the extinction of Homo sapiens in East Asia and a decline in Africa. However, since this theory was proposed in the 1990s, little evidence of severe environmental and human impacts caused by Toba have been found. The current consensus is that if the Toba eruption had an impact on the climate, it was short-lived. Furthermore, archaeological studies demonstrate that hominin populations were unaffected by the eruption. At one archaeological site in India where Toba ash fell, the same types of stone tools were used before and soon after the eruption, suggesting continuity of cultural practices in hominin societies. Other studies in Malawi in South Africa, where ash from the eruption has been found, show that vegetation and human cultures remained unaffected, refuting the idea that the Toba eruption caused a genetic bottleneck in this period. So the identity and dynamics of hominin groups from this period in South and East Asia remain mysterious, but in Southwest Asia, they are quite well understood. Here, sometimes humans made camp at Skol, Kwazi, and Al Wusta. The number of Homo sapiens declined, while Neandertals thrived. No fossils belonging to our species have been found in this region between 85,000 and 55,000 years ago. Furthermore, centripetal Lavallois tools, once used by Homo sapiens, disappeared, replaced by a new type of prepared core technique, presumably one brought into the region by Neandertals. In fact, during this period, which experienced episodes of dramatic global cooling and regional aridity, Neandertals appear to have migrated southward from Europe into the Levant and Zagros Mountains of Iran, where their fossils have been discovered at 6 sites. Some combination of environmental change and Neanderthal competition led to the local extinction of our species. This Neanderthal expansion presents a key insight. For more than 100,000 years, groups of people belonging to our species had ventured out of Africa, but all had died out, failing to expand permanently into Eurasia. Why had these dispersals been temporary, where a later migration would lead to global domination? Well, it seems like competition from Neanderthals may have played a significant role in limiting early expansions of Homo sapiens. The resistance posed by our evolutionary cousins, along with arid landscapes in Southwest Asia, may have been insurmountable barriers for a long time, but eventually, those obstacles would be overcome. Starting around 60,000 years ago, a series of events took place that changed the history of our planet. These events determined the ultimate success of Homo sapiens at the expense of all other intelligent human species. Over the course of 20,000 years, a renewed expansion of our species out of Africa took place, reaching much further than previous Eurasian ventures. By 40,000 years ago, groups of Homo sapiens would be scattered across vast new areas of land, from Spain to China and from Siberia to Australia. At the same time, 6 other hominin species went extinct. For them, this series of events was apocalyptic, their demise almost certainly caused by our arrival. Several moments of this transformative period can be reconstructed with DNA, fossils, and stone tools. From explosive expansions to failed dispersals, from interspecies encounters and rapid cultural adaptation, the colonization of Eurasia by Homo sapiens was among the most dramatic episodes of prehistory. This process, of course, began with the exit from Africa. Groups of hunter-gatherers living somewhere in Northeast Africa began migrating into Southeast Asia, either by crossing the Sinai Peninsula or the Bab al-Mandab Strait. Prehistorians believe this event took place around 60,000 years ago, based primarily on genetic data, including that obtained from people living today and prehistoric individuals. Much of what we know about the dispersal of Homo sapiens throughout Eurasia comes from genetics. So let's take a moment to understand how this works and its limitations. By examining DNA sequences, geneticists can find evidence of past demographic events, including the separation and mixing of human groups, usually due to migrations. They do this by identifying differences between the genetic code of people living in different parts of the world. When 2 populations become isolated from each other, due to random mutations, genetic differences accumulate over time. Therefore, by using the rate at which mutations occur and the average length of a human generation, geneticists can estimate the number of years since the ancestors of different ethnic groups last lived together in the same place, and by extension, the date when these groups became genetically separated. They can go further by comparing multiple populations to recreate prehistoric family trees, going back tens of thousands of years. Despite the power of these techniques for the study of prehistory, we should acknowledge some of its limitations. First, uncertainty about the actual mutation rate and generation time means that estimated dates of demographic events are not highly precise. Second, although we can use modern DNA to roughly approximate when things happened, we can't use this data to tell us where certain groups lived in the past. For this, we need ancient DNA, which unfortunately is harder to obtain in warmer parts of the world. Third, human demographic history is complex. People living today are the result of a long series of population splits and mergers. Furthermore, ancient groups become genetic dead ends, leaving no descendants alive today. Reconstructing the details of this history is difficult, and sometimes multiple scenarios could explain the information we have. Yet, over the past 3 decades, advances in the ability to sequence large amounts of DNA have revolutionized our understanding of prehistory. Among the most important insights from genetic studies was that Homo sapiens originated in Africa, an idea that had already been proposed by some of those who studied hominin fossils. However, others had argued from an alternative theory that Homo sapiens evolved separately on different continents. Europeans from Neandertals and East Asians and Africans from other local archaic hominins. But DNA revealed that people living today in Africa possess dramatically more genetic variation than those living outside of Africa. Higher diversity in Africa supports the idea that our species has lived longer on that continent than on others, providing more time for mutations to occur. Furthermore, genetic lineages found outside of Africa represent a subset of those in Africa. In other words, Eurasians are more closely related to certain East African groups than those East African groups are related to other Africans. The best explanation for these patterns is that modern-day Eurasians, Oceanians, and Americans descend from people who left Africa relatively recently and only took with them a small part of genetic variation present on that continent. Other insights from DNA sequences tell us about the out-of-Africa migrations. Based on genetic analysis, it's estimated that the ancestors of East Africans and Eurasians lived together until around 70,000 years ago. We don't know exactly when, where, or how the process of separation occurred. It's possible that they lived in the Nile Valley or Ethiopian highlands, and that genetic isolation happened when a subset of these people started migrating into Southwest Asia. These groups could have split within Northeast Africa and dispersed into Southwest Asia slightly later. This scenario lines up with some studies that suggest the separation was gradual, with the ancestors of East Africans and non-Africans remaining in contact for several thousand years, before a final permanent parting. Based on the low genetic diversity of non-Africans today, it's believed that only a small number of people made this migration out of Africa. One study estimates about 2,000 people, the equivalent of 100 bands of 20 hunter-gatherers. Interestingly, this separation coincides with a severe global ice age that lasted between 73,000 and 60,000 years ago, when North Africa, Arabia, and the Levant experienced an especially arid climate. This led to the expansions of deserts and the limitation of fresh water sources. It's hard to know exactly how environmental fluctuations influence this out-of-Africa dispersal, but however it happened, by about 60,000 years ago, a population of Homo sapiens lived somewhere in Southwest Asia, maybe the Arabian Peninsula or the Levant. The next event in the out-of-Africa saga comes with the first major encounter between this population and another hominin species. As Homo sapiens was moving out of Africa, Neandertals lived widely in the region, including the Levant and Zagros Mountains. Here they hunted wild cows, horses, and goats, and foraged wild peas and a variety of other plants. After 60,000 years ago, when environmental conditions improved, access to these resources would have been desired by bands of Homo sapiens as their population grew and they attempted to move northward. Inevitably, they spotted groups of Neanderthals hunting, gathering, and sitting around campfires. They could see that these strange humans were physically different from them. They were shorter, more muscular, with less prominent chins and foreheads and more bulging brows. But the extent to which they thought of them as a different species is hard to know. Both Homo sapiens and Neanderthals had to decide how to interact with the others. Did they choose to avoid these strangers, fight to defend their territories, or make friendly contact and attempt to communicate? We don't know. But what we can say for sure is that during these encounters, somewhere in Southwest Asia, Homo sapiens was repeatedly mating with Neanderthals. Fascinatingly, hybrid children that came from these interbreeding events were raised within Homo sapiens societies. Once adults, half Neanderthal, half Homo sapien individuals had children of their own with other members of our species. And in this way, over the course of many generations, Neanderthal genes spread throughout a large portion of the population of Homo sapiens living in the contact zone. Evidence of this hybridization event comes from the DNA of all non-African people living today, which contains about 2% Neanderthal genes. Europeans, Asians, Native Americans, and Oceanians are all part Neanderthal, a discovery made possible by recent sequencing of several complete Neanderthal genomes. The implications of these findings are significant. Despite hundreds of thousands of years of separation on different continents, Neanderthals and Homo sapiens retained sufficient biological and behavioral similarities to successfully reproduce. Furthermore, at least some groups considered it socially acceptable to have babies with Neanderthals, since hybrid children grew up with Homo sapien communities and had children of their own on multiple occasions. This paints a picture of somewhat tolerant attitudes towards Neanderthals. In addition, this interbreeding provides valuable information regarding the timing of the out-of-Africa migration. Crucially, when geneticists examine sections of Neanderthal DNA in modern genomes, they find that these sequences look quite similar in all non-Africans, suggesting that most of their Neanderthal ancestry came from the same episode of interbreeding. This means that ancestors of Eurasians, Oceanians, and Native Americans did not spread out across Eurasia until after this mixing with Neanderthals. They lived together, probably somewhere in Southwest Asia, while in direct contact with Neanderthals. Some geneticists have named this the hub population because it would become the source of multiple major dispersals across Eurasia. Determining the date of Homo sapiens Neanderthal interbreeding has been a major interest to prehistorians. The most recent estimate places this event at somewhere between 50,000 and 45,000 years ago, while a previous study put it earlier at about 55,000 years ago. This newer, younger estimate is surprising for several reasons. As we already saw, genetic studies place the exit from Africa around 60,000 years ago. If both results are accurate, it would mean that a small population of Homo sapiens survived somewhere in Southwest Asia for more than 10,000 years, before finally expanding into the rest of Eurasia. Interestingly, analysis of ancient genomes from the Caucasus and Turkey revealed the presence of a second group of Homo sapiens living somewhere in Southwest Asia or Northeast Africa around this time. This group belonged to the non-African branch of the human tree but did not interbreed with Neanderthals. Geneticists call them Basal Eurasians, and they separated from the hub population at some point before the latter encountered Neanderthals. One theory argues that these two groups occupied opposite sides of the Arabian Desert. Using both genetic and environmental information, a recent study argues that Basal Eurasians probably lived to the west of the Arabian Desert, either along the Nile River, the Levant, or the western edge of Arabia. The hub population, on the other hand, probably lived to the east of the Arabian Desert, either in Mesopotamia, the Zagros Mountains, or the Persian Plateau. This idea, known as the Persian hub theory, makes sense of various lines of information. As Homo sapiens ventured into Asia, they made their way around to the eastern side of the Arabian Desert. Here they found favorable conditions for hunting and gathering, and became genetically isolated from groups who stayed behind, the Basal Eurasians. Those who migrated further away from Africa were more likely to encounter Neanderthals, more likely to become the source of further expansion across Eurasia, and more likely to be the ancestors of modern populations. At some point, groups of Homo sapiens started dispersing out from the hub, deeper into Eurasia. The details of these movements are not completely clear, but a combination of archaeological, fossil, and genetic evidence has given us a basic understanding of events. One of the main takeaways from recent research is that the dispersal of our species across Eurasia was a complex process, involving multiple waves of people leaving the hub, some of which were failed attempts. The first evidence of movement from Southwest Asia comes from a cave in France, known as Mandarin, where teeth belonging to our species were dated to 54,000 years ago. These teeth were found alongside tools that differed strikingly from those used by Neanderthals at the time. This is several thousand years earlier than the next oldest evidence of Homo sapiens in Europe, and suggests that our species had made an early, brief, and temporary incursion deep into Europe, where the Neanderthals were still dominant. The next evidence for Homo sapien dispersal comes a few thousand years later. Genetic studies have estimated that several major Eurasian genetic lineages split apart between 52,000 and 47,000 years ago. For example, the ancestors of East Asians, Europeans, and Aboriginal Australians separated during this time. These migrations marked the first of two major waves of Homo sapiens out from the hub. The extensiveness of this migratory wave is supported by several archaeological and fossil discoveries from around the world. In Germany, Czechia, Bulgaria, and Western Siberia, 4 sets of Homo sapiens fossils have been discovered and dated to 45,000 years ago. The DNA extracted from these bones show that all of them had Neanderthal ancestry from the same interbreeding episode as all non-Africans alive today. In addition to the fossils and DNA, the appearance of new types of stone tools also marks the arrival of our species to the higher latitudes of Eurasia. In fact, in Europe, a wide range of different cultures emerged around 45,000 years ago, and several of these have been directly associated with Homo sapiens fossils. In Eastern Europe, a set of traditions emerged known as the initial Upper Paleolithic. People of this culture distinguished themselves from Neanderthals by frequently using 3 types of items: ornaments, bone tools, and stone blades. They made a variety of beads and pendants from animal bone, teeth, and stone. and long, narrow blades using a type of prepared core known as lavawa. Sites with these artifact categories started appearing around 48,000 years ago. At one site in Bulgaria, they were found with Homo sapiens bones. Interestingly, similar sets of artifacts were used by people thousands of kilometers away in the Levant and in southern Siberia. Dated to the same period, these stone tools and ornaments might be the result of long-distance migrations of people carrying initial Upper Paleolithic customs. Two other unique cultures directly associated with Homo sapiens fossils appeared in Europe around 45,000 years ago. One emerged across the northern European plain of Poland, Germany, the Netherlands, and England. Called the LRJ culture, its people produced stone blades and finely crafted leaf-shaped spear points. The other culture, called the Aleutian, formed in Italy and is characterized by tiny crescent-shaped stone tools, believed to have been tips of arrows propelled by bows. The people of these three cultures belong to the first large wave of Homo sapiens migration into Europe. Yet, in all three cases, they coexisted with groups of Neandertals. Classic Neanderthal tools and fossils are found throughout Europe, including in Eastern Europe and Italy, and it appears that this coexistence led to further episodes of interbreeding. The DNA of people living in Eastern Europe and Siberia around 45,000 years ago reveals that, in addition to the first major interbreeding in Southwest Asia, their ancestors had mated with Neanderthals more recently, within the past 20 generations. In addition, close contact with Neanderthals might have slowed the progress of dispersals into Europe. DNA of Homo sapiens show that none of the groups expanding northward from the hub contributed to the ancestry of modern-day people, meaning that these early movements in Europe and Siberia were dead ends, as in no European alive has any genetic material from these people. It seems that living in such cold temperatures, surrounded by another hominin competitor, led to these groups dying out completely. But this was not the fate of all who migrated during the first wave. Some of the migrants who left Southwest Asia between 52,000 and 47,000 years ago moved eastward, and established permanent populations whose descendants became modern-day South Asians, East Asians, and Oceanians. We know that this happened because of the DNA of people alive today. But fossil and archaeological evidence for this dispersal is scarce. Some groups probably moved south of the Himalaya mountains and into the Indian subcontinent before their descendants continued into East Asia. The people who went this way didn't use blades like the ones who went northward into Europe and Siberia. But there are some hints in India, Indonesia, and Australia that point to the arrival of new groups of humans more than 45,000 years ago. Around 48,000 years ago, microlithic tools first appeared in central India and Sri Lanka. Microliths are especially small stone tools. Like those of the Aleutian culture in Italy, they mark a significant change in the approach of stone toolmaking and are generally associated with our species. It seems likely that this technological innovation belonged to groups of Homo sapiens in South Asia. Further to the east, signs of Homo sapiens' arrival are surprisingly slightly older. In Sulawesi, a large Indonesian island, a dramatic new cultural practice appeared around 51,000 years ago. Here, humans began a tradition of painting rock walls with hand stencils and drawings of animals, a tradition that would remain in practice for thousands of years. This is the oldest known complex rock art in the world and reflects a significant cultural transformation, hypothesized to indicate the arrival of Homo sapiens. Even further east, in Australia and New Guinea, stone tools started appearing around the same time that the rock art did in Sulawesi. When our species arrived, these two landmasses formed a single continent known as Sahul, but still remained separate from the islands of Southeast Asia by 80 kilometers of ocean. It seems that Homo sapiens was the only hominin to cross this ocean barrier, so the presence of several sites of stone tools starting around 50,000 years ago represents the arrival of our species in Sahul. The genetics of Aboriginal Australians and Papuans also support an arrival around 50,000 years ago, and suggest that Sahulian colonists were descendants of those living in the hub population in Southwest Asia because they carried the same Neanderthal DNA as all other non-Africans. The surprisingly early appearance of our species in Sahul 50,000 years ago has been used to support the southern route theory. The idea that the earliest dispersal of Homo sapiens across Eurasia occurred along the coast of the Indian Ocean. It suggested that our species, adapted to life in tropical Africa, would have been able to expand across warm southern Asia more quickly than in the cold latitudes of Europe and Asia. A further aspect of this hypothesis is that the coast, where people could use boats to travel and rely on marine resources to survive, may have provided a migration highway, where travel was much easier than through terrestrial environments. The idea that cold environments delayed the expansion of Homo sapiens is also supported by the apparent late arrival in northern China, Korea, and Japan, where there is no evidence that our species arrived more than 45,000 years ago. The oldest fossil of our species here is only around 40,000 years old. And in China, evidence of cultural change only appears much later. In Korea, on the other hand, human groups started using stone blades and stemmed points around 43,000 years ago, suggesting a cultural transition due to the arrival of Homo sapiens. And finally, Japan was not colonized by humans until around 38,000 years ago, at least 10,000 years after their ancestors had left the hub in Southwest Asia. As groups of Homo sapiens moved eastward across Eurasia, they encountered Denisovans, a hominid species closely related to Neandertals. Based on genetic material obtained from fossils, we know that they lived in southern Siberia, northern China, and the Tibetan Plateau. But comparisons of complete Denisovan genomes to those of Homo sapiens suggest that their geographic range was much wider than that. South and East Asians carry a small percentage of Denisovan ancestry that resulted from an interbreeding event, probably somewhere in the Indian subcontinent. Later on, the branch of people who arrived in Sahul interbred again with Denisovans probably somewhere in Indonesia. This episode left a large genetic mark on modern-day Aboriginal Australians and Papuans, whose genome derives about 4% from Denisovans. Like the discovery of Neandertal interbreeding, these Denisovan-related findings are significant. They show that at the time Homo sapiens spread across Eurasia, Denisovans lived over a wide swath of eastern Eurasia, from Siberia to Southeast Asia. The presence of this hominin must have impacted dispersals of our species into this half of the continent. Also, the repeated occurrence of sexual encounters again highlights the similarities between us and another hominin species. Fascinatingly, interbreeding seems to have had several benefits for Homo sapiens. Many of the genes acquired from Neandertals and Denisovans were beneficial, including several that affected fat metabolism, skin pigmentation, and the immune system. This might have been key biological factors that facilitated adoption to a new continent with colder climates and new diseases. Ironically, our evolutionary cousins provided us with genes that helped us overcome them. Based on many different types of information, we can draw the following conclusions about the first major wave of Homo sapiens dispersal throughout Eurasia. It probably started sometime between 52 and 47,000 years ago. By 45,000 years ago, the descendants of these people were likely living over a vast area, including Europe, Siberia, the Indian subcontinent, Southeast Asia, and Sahul. But importantly, pioneers of these places were not equally successful. Those in South Asia, Sahul, and East Asia would become permanent inhabitants of those regions. The migrants into Europe, on the other hand, did not survive to pass on their genetic heritage. The expansion of Homo sapiens might have been aided by a relatively warm climate between 55,000 and 45,000 years ago. This might explain why so many movements across Eurasia occurred when they did. While the first wave of Homo sapiens spread to Europe, East Asia, and Sahul, the hub population continued living in Southwest Asia, and several thousand years later, it became the source of a second major burst of migrants, a burst that would end the era of interspecies contact with other hominins. But this movement of people did not go eastward. Instead, it was primarily an expansion northward from the hub population, moving into Europe, Central Asia, and Siberia. Whereas the first wave gave rise to the genetic lineage known as East Eurasians, this second wave gave rise to Western Eurasians, whose descendants today live in Europe and the Middle East, and to a lesser extent in Siberia and South Asia. Western Eurasians almost completely replaced the previous groups of our species to migrate into Europe, presumably because by the time they arrived, other Homo sapiens populations had gone extinct. The oldest known member of this genetic lineage in Europe lived 37,000 years ago in Western Russia. North of the Himalayas, Western Eurasians mixed with the descendants of the first wave, creating a group known as the Ancient North Eurasians, which would play an important role in later prehistoric events, including the colonization of America. The oldest ancient North Eurasian that we know of lived 34,000 years ago in Mongolia. The second major wave of human migration out from the hub population was dramatic. It reshaped not only the genetic landscape of Eurasia, but also spread new cultural practices. As Western Eurasians moved northward, they carried with them tiny stone tools called bladelets. Bladelets looked like stone razor blades, narrow and thin. People of the second wave slotted bladelets into grooves carved into wooden or bone components of knives and hunting weapons. They were easy to mass produce, versatile, and standardized, making them easily replaceable when implements became damaged. This approach to making tools became extremely popular across Western Eurasia. In the Levant, this bladelet-using culture has been given the name of Amarian. In Europe, the Aurignacian. In the Zagros Mountains, the Baradastian. And in Central Asia, the Kolkolakian. Evidence of this technology appeared first in the Levant around 46,000 years ago, and then in Europe around 43,000 years ago. Within a couple more millennia, it was widespread. From France and Spain in the west to Uzbekistan and Kazakhstan in the east. There's a remarkable similarity in the methods used to produce bladelets. Furthermore, in all of these locations, forgers shaped bladelets into delicate points with remarkable consistency in shape and size. The transmission of such highly specific stone knapping practices across Western Eurasia suggests that the second wave of migration moved quickly. We know from genetics that these people reached southern Siberia and Mongolia. And not surprisingly, bladelets also became increasingly common here after 40,000 years ago. By this date, two major waves of Homo sapiens had emanated from Southwest Asia and permanently settled a large portion of Eurasia and Sahul. But as we have seen, this colonization was not a straightforward process. The geographic range of our species expanded at times and contracted at others. If the most recent genetic studies are accurate, the first 10,000 years after the exit from Africa, Homo sapiens was probably still mostly restricted to Southwest Asia. Then it took another 10,000 years to finally outcompete the Neandertals in Europe and Denisovans in East Asia. Early failures to establish stable populations in new regions shows that our species suffered hardship as they explored new lands, likely due to the difficulty adapting to new environments and resistance from other hominins. But by the time the second wave of migration reached across Eurasia, all other hominins had gone extinct. Since we found lots of Neandertals fossils, we have a clear idea of when they vanished. Around 40,000 years ago they disappeared from Europe, just as bladelet cultures were spreading widely. Although our species had probably coexisted with Neandertals in Europe for around 8,000 years, the second wave of migrants out from the hub was too much for them to survive. Pinning down the extinction of Denisovans is more difficult, but we know that they lived in the Altai Mountains of Siberia until 50,000 years ago, just before our species arrived. We know even less about the two miniature hominin species from the islands of Southeast Asia, Homo luzonensis and Homo floresiensis. Homo floresiensis, standing only 3.5 feet tall, lived on the Indonesian island of Flores until about 50,000 years ago, right up until our species arrived, similar to Denisovans in Siberia. In other words, there's strong evidence that the arrival of Homo sapiens resulted in the extinction of at least 3 other hominin species. The growth of our species resulted in a dramatic reduction in the diversity of intelligent forms on our planet. So why did we live when they died? Several answers have been given to this question, including the ideas that we had superior intelligence, societies, or technologies. Some paleoanthropologists argue that the stocky, muscular bodies of Neandertals, which were adapted to withstand cold and perform physically demanding hunts of large animals, became an evolutionary disadvantage due to the high caloric requirements of this physique. Furthermore, the DNA of Neandertals revealed that inbreeding was a long-term problem for them, a sign that their populations were consistently small even before the arrival of Homo sapiens. Whichever of these factors played a larger role, Homo sapiens were able to repeatedly move into lands used by other hominins to hunt and gather. In these encounters, our species often outcompeted them, possibly restricting their access to food and forcing them to relocate to less desirable areas. This would then in turn reduce the rate of their reproduction until their populations perished. Whether or not Homo sapiens directly killed other hominins through violence or by spreading novel diseases is unknown. But one key advantage possessed by Homo sapiens that is clearly demonstrated during the expansion out of Africa is cultural flexibility. Our ability to quickly adapt to new environments may have helped us outcompete other hominids. Eurasian migrants were able to survive in different types of ecosystems. Whereas Homo sapiens in Africa primarily lived in savannas and woodlands, by 40,000 years ago, microlithic stone tools first appeared in central India and Sri Lanka, on the frigid mammoth steppe of Europe, and on the small islands of Indonesia. Survival across such varied biomes required extremely distinct lifestyles, from hunting monkeys to fishing tuna and tracking megafauna. Technological innovations enabled rapid adaptation, including the bow and arrow in the tropical forests of Sri Lanka, but also needles for making warm clothing in Siberia and fishing equipment in boats in Southeast Asia. The capacity for long-distance marine navigation, like that required to reach Australia and Japan, certainly indicates significant cognitive flexibility. These lands were never colonized by any other hominin other than us. Another sign that Homo sapiens possess unique mental qualities can be seen in the proliferation of symbolic artifacts with the dispersal across Eurasia. This is most evident in Europe, with the explosion of cave paintings, sculpted figurines, and jewelry around 40,000 years ago. but we can also see it in the ornaments of the Siberian cultures after 45,000 years ago and in the rock art of Indonesia starting 50,000 years ago. All humans that migrated across Eurasia must have had the capacity for artistic creation. We know that it arose in Africa more than 70,000 years ago. Importantly, the extent to which symbolic items were created exceeded those of other hominins, and this suggests that Homo sapiens fostered social relationships that differed from those of Neandertals and Denisovans. Stronger social networks may have been a key factor in our eventual success. These evolutionary edges meant that over the course of about 10,000 years, Homo sapiens more than doubled its range. After repeated ventures into Eurasia, the momentum of our species finally overwhelmed the other intelligent hominins. This period of expression represents a unique moment in prehistory. For a few millennia, we repeatedly came face to face with other species that shared many of our same cognitive abilities. People had to navigate social dynamics and moral dilemmas that we no longer face. Our history tells us that we have the capacity for great kindness and ugly brutality. Our hominin cousins probably received some of both. Such brief encounters would have left very little evidence behind. But at one cave we may have found a miraculous clue. Shanidar Cave is one of the most important Neanderthal sites ever discovered. This is where the famous flower burial was found, the remains of a Neanderthal that may have been buried with flowers. Shanidar 1, another find, was a very brutally crippled old man that must have been cared for by his people. This cave has been used to show that Neanderthals had complex culture and even compassion for their own. Another set of remains is much less compassionate but equally as human. An individual named Shanidar 3 has proven to be one of the most interesting found at the site. It was found to have a penetrating lesion on one of its ribs, unmistakably caused by a weapon with a stone tip. Since its discovery in the 1960s, it has been a center point in the discussion of interpersonal violence in the Paleolithic. Based on this one rib, a comprehensive 2009 paper sought out to discover just how the Neanderthal was wounded. The authors chose recreations of 3 different styles of points that were used in the region. They did 2 forms of test, a low-energy test to replicate projectiles propelled by a spear thrower, and a high-energy test to simulate a close-range stab wound. The high-energy stab test tended to impact more than one rib, and often shattered these ribs, while the low-energy test only impacted one rib and leave a sharp cut in the rib, just like is seen on the rib of Shanidar 3. This strongly suggests that Shanidar 3 was injured by a lightweight, long-range projectile, perhaps a dart from a spear thrower, or a lightweight javelin. The use of long-range, lightweight projectiles is often associated with the emergence of anatomically modern humans. Shanidar 3 is around 45,000 years old, which does coincide with modern humans living in the region. This raises the intriguing possibility that this Neanderthal was wounded by a spear thrower wielding an anatomically modern human. Perhaps our species directly attacked other species of hominids in order to take their territory and resources. Knowing the history of humanity, this is not far-fetched, but humans are complicated. Considering humans mated with Neanderthals on multiple occasions, it is clear that violence wasn't always the answer. Whatever the case, other hominid species would all become assimilated or extinct by around 40,000 years ago. It is possible that some survived in the mountain refuges or isolated islands of Southeast Asia, but they were irrelevant to the story of our species moving forward. Our species was now living all over the world. From Africa to Europe all the way into Australia, we reigned. Our most detailed evidence of this period comes from Europe, as it has been heavily excavated and studied for over 200 years. However, researchers have been discovering the same cultural complexity across the world. This period has often been called the Upper Paleolithic Revolution, which, as mentioned earlier, featured a massive rise in symbolic behavior around the world. Art appears in very sophisticated forms, and religious and spiritual practices appear. Our best evidence comes from the appearance of complex cave paintings. The oldest actual cave paintings come from Europe around 60,000 years ago. These were painted by Neandertals. Archaeologists once believed that cave painting originated with Cro-Magnon in Europe, but this view was of course a little Eurocentric. More recently in Sulawesi, Indonesia, the oldest complex cave painting made by our species was found. The 51,000-year-old cave painting depicts human-like figures and a large pig. Other paintings from the same period are found in the region, including hand stencils. The more famous cave paintings of Europe wouldn't be made for another 10,000 years. Though it is clear that by the start of the Upper Paleolithic around 45,000 years ago, painting had matured into a true art form. Chauvet Cave in France is the most impressive artwork from the early Upper Paleolithic. Here, lifelike paintings of many Ice Age animals can be found. The lions of Chauvet are truly a masterpiece. They are drawn in perfect anatomical detail starting with a clear focus. In the gaze to the upper left are prey animals which appear to be fleeing. This panel appears to be a narrative hunting scene. Other important paintings in the cave show woolly rhinoceros stacked on top of each other. Another painting shows two rhinoceros engaged in a fight. And this painting just gives you the feeling that whoever painted this saw this event happen in real life and it was just too awesome not to paint down on a cave wall. The cave also features hand stencils and more abstract paintings. To many, this cave is clear evidence that people from this period had developed the world's oldest religion, Animism. Animism is widely considered the world's oldest spiritual belief system. It is the belief that places, objects, and animals all possess a distinct spiritual essence. Animism perceives all things as being animated, meaning they have agency and free will. It is still practiced by millions around the world today, and it is really fascinating to hear these people talk about the world around them. There is inherent meaning to every thunderstorm, failed hunt, and gust of wind. The extreme detail and effort put into the paintings at Chauvet Cave suggests that these people had true passion for their work. They weren't creating art for the sake of art. Like Michelangelo painting the Sistine Chapel, these people appear to have had absolute reverence for their subjects. The Venus at Chauvet also raises many questions. The lower half of a woman is depicted next to a bison and a lion. This is the only depiction of a human in the entire cave. Its direct association with animals may suggest the development of therianthropy, the shapeshifting of humans into animals or into a hybrid form. This is most clearly seen in the famous Lion Man figurine dating back to 40,000 years ago in Germany. The carved tusk clearly depicts a half-man, half-lion figurine. To researchers, this may suggest that these people may have practiced shamanism. Shamanism is an ancient practice where a shaman enters an altered state of consciousness to communicate with the spirit world and bring back healing, guidance, or knowledge to the community. This is often achieved through rituals like drumming, chanting, dancing, and even psychoactive substances. It is based on the belief that the spiritual world and physical worlds are interconnected. The existence in a spiritual world in shamanism can be seen as the precursor to many modern religions that likely descend from both animism and shamanism. Shamans often wear animal costumes to embody the spirits of animals and to act as the intermediary between worlds. The costumes are not just symbolic. They are believed to contain the powers of the spirits. As such, the existence of hybrid human-animal figurines this early on suggests that shamanism may have existed and in turn, possibly the earliest roots of religion. The earliest musical instruments also appear during this time, further testifying to the development of the arts during this period. Another important form of art during this period was Venus figurines. They appeared all over Europe and across the Eurasian steppe. These figurines depict abstract forms of women. They are often quite plump for the Ice Age, which is unusual because it is rare for hunter-gatherers to gain this much excess body weight. But excess body weight would have certainly helped women during their pregnancy and while breastfeeding. These figurines may have had deep symbolic meanings surrounding fertility or even depict some kind of mother deity. Whatever the case, they are further evidence of a sophisticated symbolic culture. Though once again, other regions prove that this was not limited to the Eurasian steppe. Australia in particular was home to many artistic traditions dating far back in prehistory. It is estimated that some paintings date back over 40,000 years, though it is impossible to date some paintings if organic paint isn't used. The oldest confirmed painting from Australia goes back to 28,000 years ago, proving their artistic traditions date back to the early Upper Paleolithic. During this period, many practical developments were also made. Bone-eyed needles were certainly in use, which allowed much more complex, airtight clothing to be made. As far as we know, Neandertals never created eyed needles, and their invention certainly made our species able to withstand much colder temperatures. We also see the earliest evidence of the spear thrower, also known as the ocelot. This weapon allowed us to throw projectiles much faster and at a much safer distance, allowing us to stay out of danger. The earliest evidence comes from projectiles in Europe, and also the 40,000-year-old skeleton of Mungo Man in Australia. His skeleton shows evidence that he used the spear thrower his entire life. If true, this would suggest that the spear thrower may have spread out of Africa with our species, and perhaps this is supported by the Neandertal Riebechen and Art Cave. It is also possible that the bow and arrow was present in various areas throughout Eurasia, and it certainly was present in Africa. The bow and arrow isn't necessarily superior to the spear thrower. It depends on the context of its use. Either way, both the spear thrower and bow were crucial technologies to the people of the Upper Paleolithic. It allowed them to keep their distance from their prey, reducing the chance of injury. Almost every Neanderthal skeleton shows evidence of physical trauma. This is of course because they hunted up close and personal, often with thrusting spears. Our long-range projectiles reduced these injuries, but life was still extremely dangerous during this time. Another significant invention across much of the world was the rise of composite projectiles. They consist of an organic haft with stone blades inserted into its edges. This creates a strong projectile or knife with replaceable stone blades on its edges. As we've mentioned before, this technology dominated the Upper Paleolithic. Hunters could carry a core with them and hundreds of blades could be removed, making it so that the edges of their weapons and tools could be replaced with ease, effectively giving these humans unlimited cutting edges. But in other areas of the globe, unique technologies were developing. In Border Cave, South Africa, archaeologists discovered the earliest evidence of poison. It was found on a wooden applicator dating back to 24,000 years ago. Chemical analysis revealed ricinoleic acid, a toxin derived from castor beans. In the same cave, they found beads, bone arrowheads, and pigment dating back to 44,000 years ago, artifacts unmistakably linked to the ancestors of the San. The San are one of the most unique human populations on Earth. Genetic studies show that they split from the rest of humanity over 100,000 years ago, making them one of the most ancient surviving lineages. But you shouldn't be mistaken that this means that they were primitive in any way. They were using the bow and poison arrows long before anyone else, and it is a good example of how innovation didn't stop in Africa just because it was also happening elsewhere. However, one of the most important innovations of the Upper Paleolithic comes from Central Asia, the domestication of the dog. There is still a lot to be learned about how and when these animals were domesticated, but evidence suggests that they may have been independently domesticated in both Western Eurasia and East Asia, but genetically, only the East Asian lineage survived. Initial phases of domestication seem to have occurred over 30,000 years ago, and by 26,000 years ago onward, dogs were fully domesticated. The earliest physical evidence of a dog comes from 14,200 years ago, preserved in a burial, but of course they existed much earlier. Dogs were the first animals that humans ever domesticated, and they remain inseparable from many households to this day. It is really remarkable when you think about it. These domesticated wolves live in our households even though they have no practical use for most of us. But back during the Upper Paleolithic, they became an essential technology for many. Dogs can be used to directly hunt animals, and perhaps more importantly, defend their owners against dangerous animals. During the last glacial period, the Eurasian steppe was full of dangerous animals such as scimitar cats, cave lions, hyenas, and wolves. Just like the African savanna in the modern day, it was an extremely competitive environment that often resulted in conflict. Just the smell of a dog alone can be enough to ward off predators or scavengers like bears. If a confrontation does occur, dogs are excellent at harassing and even attacking large dangerous animals. They are also great at tracking prey and chasing down highly mobile animals. Dogs were also undoubtedly a food source. Though it sounds very sad to many of us, dogs have been eaten since the very beginning. We may have even raised them in some part as an emergency food source. But this doesn't mean we didn't have a close, intimate bond with them. The Oberkassel burial from 14,200 years ago proves that Upper Paleolithic people did view dogs worthy of burial and likely affection. We know that Inuit communities have very deep connections with dogs, but also would eat them on occasion when times got tough. To many Upper Paleolithic people, they were essential to the way of life, and this bond cannot be underestimated. Dogs may have also helped to hunt massive animals including bison, woolly rhinoceros, and even mammoths. Though on average smaller game was chosen such as reindeer, we do know that Upper Paleolithic people did take down the largest animals of their world from time to time, and the Yana rhinoceros horn site proves it. This site is one of the most important from the Upper Paleolithic. This is due to the fact that it is the earliest archaeological evidence for human settlement north of the Arctic Circle. Dating back to 32,000 years ago, it is proof that even by this time, humans were able to thrive in the far north. The site also provides the earliest unambiguous evidence of mammoth hunting by humans. 100 mammoth bones are found at the site, including multiple with stone points embedded in them. The age demographic of mammoths even suggests that they were hunting a specific age in order to get access to straighter tusks. Overall, this site proved that they were underestimating the capabilities of Upper Paleolithic people, and it also has implications for the peopling of the Americas. The peopling of the Americas is one of the most significant events in prehistory. Homo erectus, often considered the first humans, spread around much of the world nearly 2 million years ago. That is, except Australia and the Americas. Neither of these continents had ever seen a human until our species arrived. The first travelers to these lands were undoubtedly seasoned survivors, and luckily for them, they walked into the richest hunting grounds the world had to offer. Unlimited fish could be found running in the rivers, while endless megafauna roamed. All of these animals were absolutely oblivious to the danger of humans. They didn't fear their smell, their figure, or even the flight of their spears. But the real question is, when did people actually make it to the Americas? This is of course one of the most contentious topics in archaeology, but the debate has led to amazing research. First of all, as we established with the Yana site, humans were able to live north of the Arctic Circle 32,000 years ago. At this time, humans would have been able to simply walk across the Bering Land Bridge. In truth, it shouldn't even be referred to as a land bridge. This was not a small passage between continents. Beringia was about 1,000 miles or 1,600 kilometers wide. Ancient humans living in Beringia may have not even understood that they were living between two continents. Beringia was full of expansive grasslands, which would have been home to millions of animals. Though much of the archaeological evidence has been lost to the sea, we know that humans lived there, and possibly over 30,000 years ago, made their way into the Americas. You see, the biggest barrier to human migration to the Americas were the massive ice sheets that blocked their way. But this barrier didn't close until around 26,000 years ago, and it would stay blocked until roughly 13,000 years ago. But since humans were living nearby in the Arctic 32,000 years ago, it is possible they simply walked into the Americas before the ice sheet closed. However, we simply do not have archaeological evidence for this idea. The oldest evidence we have of humans in the Americas at this time are the 21 to 23,000 year old footprints at White Sands National Park. At this time, passage to the Americas would have been impossible by land. It is possible that the ancestors of these people migrated much earlier, or came via a coastal route on watercraft. Many archaeologists favor this so-called Kelp Highway hypothesis, and it would align with the genetic evidence that suggests Native Americans split off with East Asians and entered the Americas only around 17,000 years ago. This genetic evidence adds another layer of mystery over the White Sands footprints. Could this have been a population that died out, leaving no trace in modern Native American genetics? It is possible, we just don't know until we get actual DNA from skeletal remains dating back to this period. Whoever made it to the Americas first is an interesting question, but as for the course of human history, the Clovis culture would play a crucial part. It was once thought that the Clovis culture was the first to enter the Americas, and this was thought mainly because the Americas were more or less a ghost town before Clovis, and then within a couple hundred years, tools appeared all over North and South America. It is really astounding how successful the people of this culture were. This gave archaeologists the impression that this represented the first group of people making it to the continent. But now it seems more of a technological and cultural revolution. The people not only developed sophisticated fluted points, but undoubtedly very sophisticated hunting techniques to dominate the megafauna of the Americas. Butchering sites proved that they were hunting massive bison and even mammoth and mastodon. The idea that the Clovis people hunted mammoth is not as controversial as it used to be, but their direct involvement in their extinction is still debated. However, the appearance of the Clovis culture is associated with the decline of many animals. Another culture that made fishtail points seems to have played a hand in the megafaunal extinctions of South America as well. But before we talk about the end of the Pleistocene and the extinctions of many animals, we have to talk about one of the most important cultures in human history, the Natufians. Back in the Old World, populations had been settling into their ecosystems for thousands of years. Many became less nomadic as they learned to better exploit local food sources such as smaller animals, seafood, and wild plants. One such population was the Natufians, living in the Levant region. The Natufians hunted wild gazelle, but more importantly, they exploited wild cereal crops. They would eat these grains whole and also grind them up using stone mortars to produce flour. we have evidence that by 14,400 years ago, they were creating primitive bread, and 13,000 years ago, they may have been even making beer. This influx of calories from abundant wild grains also allowed these populations to settle down and make permanent villages. Keep in mind, the vast majority of the world simply couldn't do this at this time. In order to feed themselves from the land, they had to constantly follow their prey and move to unexploited areas to forage. Now, some populations were located by salmon runs or exceptionally productive tropical environments and were able to settle down for part of the year. But the vast majority couldn't set up permanent villages for the entire year. But the Natufians could, and this led to the development of complex permanent architecture. At the 14,300-year-old site of Ain Malaha, dwellings were made by digging into the earth, paving the floor with stones, and constructing dry stone walls. Wooden posts were then put into the ground to support the roof, which was made of thatch or animal hides. This created a semi-subterranean hut that stayed cool in the summer and warm in the winter. And a total of 50 of these structures were constructed. At other sites, the Natufians created complex stone structures which required quarrying techniques. The Natufians had been carving hard basalt to create mortars for millennia. But these techniques of shaping hard stones began to be used for symbolic purposes such as carvings and even human figurines. The Natufians even began quarrying large sandstone slabs, which were not only functional but monumental. These building techniques would eventually develop into massive planned structures optimized for community living. At some sites, archaeologists have even uncovered structures that appear to have been used to store wild grains. This would have allowed these people to build up food supplies throughout the year and even trade food with others. But to be clear, at this time, these grains were not domesticated. The early days of agriculture were subtle and unintentional. At first, these people may have just cleared away native plants so that wild cereals had less competition. There is no doubt that they understood that seeds could make new crops, and thus they could plant wild cereals in new, more productive areas. In time, the wild cereals themselves would evolve to be more productive, and agriculture would truly be born. It is hypothesized that the Younger Dryas may have spurred on this development. The Younger Dryas was simply a 1,000-year-long cold phase at the end of the last glacial period. It started around 12,900 years ago, and was a challenging period for both humans and animals. The cold, dry conditions made life difficult, but this period wasn't apocalyptic as some claim. Research has never proven that a comet or meteor impact caused this cooling period, nor even occurred. The drying climate would have led to less area being suitable for wild cereals. These already sedentary populations which had come to rely on these crops would have come under stress. This may have forced their hand in learning how to plant seeds for themselves in especially productive soil. This would have led to designated fields and choosing to replant only the most productive crops. This artificial selection would be the basis of domestication. But plants wouldn't become fully domesticated for some time. A few hundred years after the Younger Dryas came to an end, and conditions became more favorable, we start to see important changes in this region. Larger settlements became more common and feature complex communal structures. The site of Halan Semi shows that a large communal structure was created and cared for many generations. Its walls were covered in plaster, and bull horns were even hung up on the wall. This space was clearly special to its inhabitants, perhaps one of the earliest worship centers ever created. The skills these populations developed over thousands of years creating settlements and carving stone would culminate into a site you have probably heard of, Gobekli Tepe. Here, a massive complex of stone structures was created starting 11,500 years ago. This site was a major revelation in archaeology, because it proved that long before massive agricultural societies formed, cultures of hunter-gatherers were able to organize and create monumental architecture. To this day, no evidence of agriculture has been found at the site, while other remains affirm that the people here were hunting and gathering. Since its discovery, archaeologists have found many other sites such as Halan Semi and earlier Natufian settlements that show how it was possible for these populations to create such a site. They harvested wild grains in abundance and coordinated massive hunts of wild gazelle, giving them large food stores in order to put time constructing their communal buildings. These structures are full of artistic carvings and the T-shaped pillars are massive. These pillars are actually highly stylized depictions of humans. The top of the pillar is the head, while the lower section is the body. You can see the long arms on the sides, while even a loincloth is worn. Smaller statues with facial features confirm that these really are giant stylized statues. It has been hypothesized that these depict venerated ancestors. Ancestor worship is common throughout early and even modern cultures, and this very well may be the case at Gobekli Tepe. Around the same time Gobekli Tepe was being constructed, other populations across the Fertile Crescent would fully domesticate multiple crops. This was of course the result of centuries if not millennia of experimentation, and archaeologists are not able to point to one exact time and location. But they do know that by 11,000 years ago, emmer wheat, einkorn wheat, hulled barley, peas, lentils, bitter vetch, chickpeas, and flax were cultivated in the wider Levant region. They appear virtually simultaneously, though some crops such as wheat were of primary concern. This is because wheat could be turned into bread, beer, and gruel. It could also be combined with other crops like peas and lentils to make nutritious soups. Around this same time, many animal species were also domesticated. These people already had domesticated crops. Perhaps understanding that animals could be tamed, they realized instead of just systematically hunting their prey, they could keep them and breed them. Pigs, goats, and sheep were domesticated around 11,000 years ago in Mesopotamia, and cattle were domesticated around 10,500 years ago in Turkey. It is worth noting that humans had symbolic connections with animals for tens of thousands of years at this point. Cave art from around the world prominently features depictions of animals rather than just humans. Animals seem to have been sacred to just about every Stone Age culture, and these connections to their prey may have culminated into true domestication during this time. Now, unlike their Natufian forebearers, they did not even need to hunt, though likely still did to supplement their diet or just for entertainment. But with plenty of species of plants and animals that sustain themselves, they had everything they needed to live a permanently settled life. Agriculture and civilization had finally formed, and this would serve to be the most profound change in human life since we had first made stone tools. The benefits and consequences on our new way of life were almost immediately apparent on our bodies. When humans shifted from the wild, varied diet of hunter-gatherers to the smaller menu of early farmers, the effects were written into our bones and teeth. Early agriculturalists began consuming huge amounts of starches from cereals like wheat and barley, while protein and micronutrient diversity declined. Archaeologists can see this in their skeletons: shorter statures, more brittle bones, and clear signs of nutritional stress. Average height in many regions fell by as much as 6 inches compared to the foragers who came before. The new carbohydrate-heavy diet introduced problems that our ancestors had never faced before. Hunter-gatherers rarely suffered from cavities because their food was fibrous, low in sugar, and rarely stuck to their teeth. But once we began eating soft, starchy gruels and bread, our mouths became breeding grounds for bacteria that thrived on leftover carbohydrates. Skeletons from early farming villages show widespread dental cavities and enamel wear, evidence of a diet that was both monotonous and rough on our teeth. Nutritionally, relying on just a few stable crops meant people developed iron and vitamin deficiencies. This led to weaker immune systems and horrible skeletal deformities. Diseases also spread more easily in denser, sedentary communities surrounded by domesticated animals. While the new lifestyle eliminated the daily physical risks of the hunt, such as an aurochs horn to the guts or falling off a cliff, the lives of these people were still physically demanding. Farming required repetitive, back-breaking work. Grinding grain led to deformities of the hands and arms. Hauling water put strain on the spine, and planting crops was gruelingly repetitive. The once dynamic, mobile bodies of hunter-gatherers were replaced by those conditioned for endurance and repetitive labor rather than bursts of speed and athleticism. This shift was so profound that humans ever since have struggled to keep up optimal physical fitness in a sedentary world. But perhaps the most surprising adaptation was that our brains began to shrink. Over the last 10,000 years, the average human brain has decreased by roughly 150 millimeters, about the size of a tennis ball. The causes are debated, but agriculture likely played a role. For the first time, people lived in large, stable communities with rigid social hierarchies and specialized labor. Individual survival no longer depended solely on personal ingenuity or physical skill. It depended on the collective. With food production centralized and tasks divided, mental demands became more specialized and less universally strenuous. In other words, we no longer needed to be generalists. Combined with a less nutritious and calorically dense diet, the brain may have simply optimized itself for efficiency rather than size. But this also led to the most rapid technological advancements yet seen in our species. Sedentary life allowed for full specialization. meaning some people could dedicate all of their time and mental energy on crafting tools, brewing beer, building structures, or managing trade. This division of labor laid the foundation for complex societies, but it also tied people more rigidly to social roles and hierarchies. A farmer's son would likely remain a farmer, and a potter's daughter, a potter. Social hierarchies would be very important when communities coalesced into full-scale cities. By 11,000 years ago, the settlement of Jericho had become massive. Numerous circular dwellings were made of clay and straw and featured hearths within homes. Around the entire settlement was made a massive stone wall 3.6 meters or 12 feet high and 1.8 meters or 6 feet wide at its base. A stone tower built on the wall was 8.5 meters or 28 feet tall with 22 stone steps. Funnily enough, this may have been the tallest structure on Earth at the time. The wall and tower may have served defensive purposes, protecting inhabitants from raiders or floods spilling from the nearby Jordan River. Archaeologists estimate that these structures would have required hundreds of laborers working for months, suggesting organized leadership and a shared community goal. Population estimates range from a few hundred to a few thousand people. The existence of a fortified town this early in prehistory is extraordinary. While violent conflicts predate agriculture, permanent settlements and stores of food made organized warfare and raiding far more rewarding. Jericho also reveals a deeper spiritual world. Archaeologists have uncovered plastered human skulls, their faces recreated in lime plaster and shell eyes staring outward. Jericho was also home to complex artwork and strange plastered skulls that may have been a form of ancestor worship. Thousands of years later, further north in Anatolia, another settlement arose, Çatalhöyük. Here, people lived in densely packed mud brick houses with no streets between them. Families entered their homes through ladders on their roofs, walking from building to building across an interconnected skyline of clay. Inside, the walls were painted with murals of bulls, vultures, and humans, possibly depicting hunting scenes or spiritual visions. Burials were placed beneath the floors, sometimes with treasured objects. Among the artifacts was a striking seated female figurine, often called the seated goddess or mother goddess, possibly symbolizing fertility or the abundance of the harvest. Living in such dense settlements meant more minds working together, which accelerated creativity. This inevitably led to unprecedented innovation. Inventions are statistically just a numbers game. More people, more fresh takes, and technology will improve. This is largely why we are living in such unprecedented periods of growth. Just look at a population graph. For the earliest settlements, it would still take quite some time to develop things like the wheel or writing, but they were pioneers. Some of the earliest evidence of copper working comes from Çatalhöyük. Copper beads were simply hammered out of naturally pure copper from nearby sources without smelting. Though this isn't all that incredible, it shows that these people were experimenting with new tools. I should also pause to mention that copper tools and weapons were widely used in the Great Lakes region of North America starting at least 9,500 years ago. Check out my documentary to learn more about that. This is a good time to zoom out of this one region and look at what was happening around the rest of the world. Agriculture first appeared in the Fertile Crescent and would spread quickly around the region. But in at least 7 other places, other crops would be independently domesticated very early on. Since we know that plants take centuries if not millennia to be domesticated, it is clear that many other populations were advancing long before we have direct evidence for. In East Asia, farming began around the same time as in the Fertile Crescent. Along the Yangtze River, people began cultivating rice about 10,000 years ago. They drained wetlands and replanted seeds from the most productive plants year after year. Further north along the Yellow River, different communities began growing millet, a drought-tolerant grass. Both of these communities domesticated these crops independently, and they would only meet one another around 8,000 years ago. This was the basis for Chinese civilization. The most surprising independent invention of agriculture has to come from the highlands of Papua New Guinea. Here, people began cultivating multiple plants starting at least 10,000 years ago. At a site called Cook Swamp, archaeologists discovered ancient drainage ditches and garden plots, showing that early farmers were managing wetlands to grow crops. But these people didn't have grasses like wheat or millet. Instead, they domesticated native tropical plants. Their main crops included taro, yams, bananas, sugarcane, and pandanus. This early horticultural system was small-scale but highly organized, relying on careful water control and soil management. While isolated from the rest of the world, New Guinea's farmers discovered agriculture on their own. proving that civilization can grow anywhere people learn to work with the land. And the agricultural communities of the Americas attest to this. In the tropical lowlands of Mesoamerica, corn, beans, squash, and gourds began domestication around 10,000 years ago. Corn is one of the world's most important crops. It is remarkable that these people were able to transform the wild teosinte grass into the corn we know today. But even more ingenious is how these crops benefit each other. You may have heard of the Three Sisters. It is a method of farming where corn provides the stock for beans to climb. The beans enrich the soil with nitrogen, and the squash spreads across the ground to block weeds and retain moisture. It really does blow my mind that ancient farmers were able to create this system solely by artificial selection. Further south, we come across one of the most impressive agricultural systems in the world. Across the Andes, populations domesticated potatoes, peanuts, cassava, and squash by 10,000 years ago. By 7,000 years ago, they had domesticated quinoa, peppers, tomatoes, and also the llama and alpaca. They developed thousands of varieties of potatoes and other crops to better suit various environmental conditions and culinary uses. Llama and alpaca were also exceptionally useful in the rugged terrain of the Andes. They were used for transport, wool, and meat. It's worth noting that the Americas do not have any native draft animals suitable for domestication. Horses went extinct over 12,000 years ago in most places, and bison are still not domesticated in the modern day. This had drastic effects on the development of both North and South America, as they had no beasts of burden like the Old World. But in the key centers of civilization in the Americas, multiple crops were fully domesticated around the same time as the Old World. You may be beginning to wonder why, all of a sudden around 10,000 years ago, agriculture appeared in 7 different regions independently after being absent for nearly 300,000 years of human history. The answer largely lies in climate. During the last glacial period, much of the northern hemisphere was locked in cold, dry, steppe-like conditions that made farming impossible. Even regions that are now fertile, such as modern-day Ukraine, known as the breadbasket of Europe, were far too cold, with short summers that couldn't support the growth of crops like wheat. But around 11,700 years ago, the last glacial period ended, ushering in the Holocene, a new era of relatively warm and stable climate. This stability allowed wild plants and animals to flourish in predictable patterns, making it possible for humans to experiment with sowing, herding, and storing food. Because this warming and stabilization was global, populations around the world got the opportunity to develop agriculture at around the same time, hence why we see the pattern that we do. But 2 other independent agricultural traditions appeared later in the mid-Holocene. In the eastern woodlands of North America, local peoples were cultivating plants like sunflower, goosefoot, and sumpweed for their oily seeds. Though these crops were later overshadowed by Mesoamerican crops, it is another example of independent domestication. Several regions in Africa also domesticated their own native crops before agriculture spread from the east. In the Sahel, people began cultivating sorghum, millet, and African rice around 7,000 years ago. Further south in West Africa, farmers domesticated yams, oil palms, okra, and cowpeas, forming the basis of tropical agriculture. Europe and Australia are the only continents which didn't independently develop agriculture. Europe is connected to the wider Eurasian continent, so they got agriculture pretty early on from the Near East. Australia never developed agriculture mainly due to the climate and lack of suitable crops. And agriculture wouldn't spread until relatively recently due to its isolation. Generally, agriculture spread around the world quickly, but many regions were not very suitable for it. In dry and cold environments such as the Eurasian steppe or northern Africa, plants could hardly be grown. These people instead adopted pastoralism. Pastoralism consists of constantly herding cattle, sheep, or goats to new grazing grounds. This allowed populations to thrive in areas otherwise impossible with agriculture. By 6,000 to 7,000 years ago, the Neolithic Revolution had spread agriculture around much of the world. Both farming and herding led certain individuals to accumulate wealth that was able to be taken by force. The rise in population and wealth also led to the rise of brutal organized warfare. To be clear, warfare likely dates back well over 10,000 years around the world. At the Nataruk site in Africa dating to 10,500 years old, 27 hunter-gatherers were killed with obsidian arrows and blunt force weapons. Some were even bound and possibly drowned. This included a heavily pregnant woman. The site is one of many that proves humans have always been capable of extreme cruelty. However, the advent of civilization, land ownership, food stores, and wealth undoubtedly spurred conflict into what we would identify as truly organized warfare. Conflict also arose as Neolithic farmers spread into new territory already inhabited by hunter-gatherers. Farmers would naturally settle in the most fertile areas of new territory, such as beside rivers or lakes, areas that were once productive hunting grounds. At a site in Spain known as Els Trocs, we see evidence that migrating Neolithic farmers were massacred by the native hunter-gatherers. 5 adults were fatally shot in the cranium, while their children show evidence of blunt force trauma. Clearly, competition had led these populations to violence, but this site is tame compared to the warfare brought on when 2 Neolithic populations went to war. The site of Schletz in Austria gives us a glimpse into the brutal reality of Neolithic warfare. Here once existed a fortified Neolithic farming village. It has a ditch and a wall surrounding it, suggesting the inhabitants had a reason to fear. They were right, as in one event, 200 of them were massacred by another group. Their skulls show evidence of fatal blows from stone axes, and in some cases arrow wounds. Hardly any young women were among the dead, suggesting they were captured. At 7,000 years old, this is some of the oldest evidence of one population exterminating another over land and resources. There are many other sites from this same time period that show violence was a common occurrence in the loosely organized world of the Neolithic. Despite the existence of violence during the Neolithic, it was one of the most significant periods of technological advancement in human history. Stone tools continued to be used, though they became even more sophisticated. Many cultures truly mastered knapping stone, but one technology would transform the world: ground stone tools. Have you ever seen those pictures of the Scottish Highlands and thought, where are all the trees? Well, they were cut down by Neolithic farmers thousands of years ago. Now, of course, they were also cut down during other periods, but much of the region was actually deforested during the Neolithic. And this was carried out by stone tools that were ground into shape. This created symmetrical axe heads that could cut much more efficiently than the jagged edges of knapped blades. Ground stone tools were developed all over the world, helping early farmers clear vast swaths of forest. The technique of grinding down stone tools was monotonous, but made durable axes, adzes, chisels, and even mace heads. Another technological breakthrough during this time was ceramics and pottery. The oldest ceramics actually date back to 30,000 years ago, when Gravettian hunters made small figurines, though this technology was never applied to functional use. The oldest ceramic vessels date to around 20,000 years ago and are found in a cave in China. Pottery and ceramics would appear in various places and were functional, but it wasn't until the Neolithic that this technology truly proliferated. Ceramics were extremely useful to Neolithic people that lived in settled villages. They could be used to store food in dry conditions that rodents couldn't get to. They can also store liquids and even be used to brew alcohol. Pottery is also exceptionally useful for cooking. It allowed these people to create slow-cooked meals with many ingredients. At a site in Denmark, researchers found evidence that deer and fish were cooking in a pot with ground-up garlic mustard seeds. Though it may sound simple to us with all of our modern luxuries, such a meal must have been very nutritious and flavorful to a people used to eating much more mundane meals. Combining spices, wheat, and meat would have fed a whole village. Seemingly innocuous technology like pottery can be truly transformational to the nutrition and health of a community. Another advancement of the Neolithic was complex weaving and basketry. While both undoubtedly existed much earlier, the Neolithic saw the invention of the loom and more developed textiles in general. 6,000 years ago, one of the most important animals in history was domesticated: the horse. They were originally domesticated for food in the modern area of Ukraine and Kazakhstan. The Bowtie people in Kazakhstan used horses primarily for their milk and meat. But these horses couldn't be ridden due to their temperament and physical limitations. It would be another 1,800 years before horse riding was mastered in the same region and quickly became useful for transport and warfare. Another foundational development was the wheel. The wheel seems to have been invented in multiple places around the world, but the best known evidence comes from potter wheels in Mesopotamia. However, some evidence suggests that miners in the Carpathian Mountains were using them earlier. Either way, between 4,000 to 6,000 years ago, this technology would spread around Eurasia in the form of wheeled carts and animal-drawn wagons. During the Neolithic, a new period would also begin to emerge, the Chalcolithic. Chalcolithic literally means copper stone, because at this time, The populations were using both copper and stone tools alongside one another. As mentioned earlier, copper tools were first used in the Middle East and North America independently of one another. This was done by turning metallic copper deposits into tools. This copper can simply be turned into tools by heating it up, quenching it, and then hammering it into shape. In North America starting 9,500 years ago, populations here created expansive mines into solid bedrock over 60 feet deep and 30 feet wide. They turned this copper into complex tools by heating it up and cooling it, softening the copper so it could be manipulated into very sophisticated tools. This was the earliest widespread use of metal tools in the entire world. People often discount this use of copper because these populations never smelted ore. But they didn't need to. The copper was already pure. Smelting is simply the process of melting a metal out of its ore. These populations essentially skipped this step due to the geology of their region. But most of the rest of the world wasn't as lucky. Copper is actually one of the most abundant minerals in the Earth's crust, though it is present in ore bonded with other minerals. The earliest copper use in Eurasia was mainly as pigment. Copper ore is often bright green in color and was ground up to be used as paint. Smelting may have first been discovered by firing pottery. When firing ceramics, potters may have noticed metallic impurities melting out of certain materials. By firing these materials, such as malachite ore, they would have melted copper into a usable metal. We may not know exactly when or where copper was first smelted, though we know that by 8,000 years ago, cultures in southeastern Europe had developed this craft. The Vinca culture in particular created complex casted objects. They mined copper, lead, gold, and tin, turning them into metallic artifacts such as axes and jewelry. The axes may have been used for tools and weapons, though stone tools were still used for the vast majority of tasks. They fully understood how to create functional tools out of metal, but you have to keep in mind how labor-intensive this process was in comparison to creating stone tools. It requires mining, processing ore, collecting fuel sources, creating a complex furnace, smelting ore, casting the object, and finally grinding and polishing the tool. In comparison, a stone axe or arrowhead can be made by one craftsman in less than an hour. Perhaps you can understand why this culture still mainly used stone tools, and why metallurgy would take thousands of years to spread around the world. Metal tools at first were mainly status items used by elites, but eventually their functional use would grow in importance. Fast forward almost 3,000 years, and copper tools were still only trickling throughout Europe. Wotzi the Iceman is the most famous example of a Chalcolithic person. Most of his tools are made out of stone or wood, with the exception of his copper axe head. Copper artifacts were still relatively rare during this time period, though they did begin the slow replacement of stone tools for everyday tasks. At around this same time, one of the most important inventions of all time occurred. Far away from Otzi's icy mountaintop grave, the bustling towns of Mesopotamia were developing something special. Around 5,400 years ago, Sumerian cuneiform first appeared. It began as simple pictographs representing certain goods, but evolved into abstract symbols representing sounds and ideas, becoming the first known writing system. It was developed to keep records of crops and livestock. Over time, it would begin to cover a wide range of legal and religious texts, eventually creating works like the Epic of Gilgamesh about 1,000 years later. The early days of writing were slow and subtle, but of course this invention would eventually transform society. But why was writing so important? Before writing, all knowledge had to be memorized and passed down orally. Think about it. Every law, story, trade deal, and religious belief was relegated to the mind. And if you have ever played telephone, you understand how fallible memory can be. Writing made it possible to store ideas permanently. This meant societies could accumulate and refine knowledge over generations instead of starting from scratch each time. Written language allowed scholars to build upon the work of others, leading to the cumulative growth of knowledge that defines science, philosophy, and literature. Without writing, there could be no libraries, no books, and no universities. Large complex societies like Mesopotamia, Egypt, and later China and Mesoamerica depended on writing to function. It allowed these large societies to record taxes, keep track of land ownership, crop yields, and trade shipments. Writing became essential to governments and economies organizing large populations and managing surplus goods. And I actually just learned while researching for the first time that Mesoamericans developed writing over 2,600 years ago. Writing also allowed ideas, laws, and inventions to travel further than any single person could. Philosophies, religions, and technologies spread through written texts. Early systems of law like Hammurabi's Code could keep people in line, while philosophies could inspire the soul. Writing made knowledge portable and universal. Writing also made possible something profound that clearly we all enjoy: history. Earlier oral traditions could preserve stories and myths. We know that some Australian myths record real events and animals from over 10,000 years ago. But written history could preserve actual dates, names, and eyewitness accounts. This marked the true beginning of history. One of the earliest historical accounts is one of the strangest: the Sumerian Kings List. It was compiled nearly 4,000 years ago and attempts to record every ruler of Mesopotamia from the very beginning of time. It starts with mythical kings who reigned for impossibly long lifespans, some over 10,000 years long. They supposedly ruled before the flood, which shows us that flood myths were widespread in this region long before the Bible began to be written. As the list moves forward in time, the fantasy slowly gives to real, historical kings of early Sumer. The Kings List is part myth, part propaganda, and part history. It legitimizes the power of modern kings by using myths of ancient ones. It is an excellent example of how supposed historical accounts can be used for power and social control. Around this time, we also get the first historical accounts of warfare. Cities like Uruk, Lagash, and Kish became powerful enough to maintain permanent workforces. Scribes meticulously recorded how much grain, beer, and oil each worker received. Most of these entries are about farmers and laborers, but some are labeled as Lu Aaron, literally meaning man of war. This suggests that these cities were maintaining professional state-funded standing armies. This appears in tablets over 5,000 years old, long before standing armies appeared anywhere else. In this region, plenty of other evidence of warfare has been found dating to this period. The settlement of Hamukar was destroyed 5,500 years ago. Thousands of sling bullets indicated that the city may have been under siege, possibly by Uruk expansion. Other fortified settlements and cities show evidence of violent conflicts and siege warfare. Clearly, this was the beginning of state-sponsored military warfare and conquest. Militaries were growing in complexity into machines that were capable of creating suffering on an industrial scale, a pattern that would define human history as we moved forward. Though this conflict was brutal, conglomerations of power would form into the first empires, bringing some regional stability. The first empire was founded by one of history's most legendary figures, Sargon of Akkad. He wasn't born into royalty. Some stories claim he was the child of a priestess, set adrift on a river like Moses, and then found and raised by a gardener. Whether or not this is true, what matters is that Sargon rose from obscurity through talent, ambition, and military skill. Before Sargon, Mesopotamia was a patchwork of independent city-states like Uruk, Lagash, Kish, and Umma. Each was ruled by their own king, each constantly fighting over farmland and tribute. Sargon initially served as a high official to the king of Kish, but he eventually overthrew him. He seized the city and then turned his attention to the rest of Sumer. Around 4,330 years ago, Sargon defeated Lugal-Zagassi of Uruk, the last great Sumerian king. With that victory, Sargon united the northern Akkadian-speaking people and the southern Sumerian-speaking people of Mesopotamia under a single ruler for the first time in history. This was the birth of the first true empire. Sargon's military campaigns reached the mountains of Anatolia, the deserts of Syria, and the plains of western Iran, binding distant lands into a single political system. The empire continued under his descendants before eventually and inevitably falling apart. But the idea of the Akkadian Empire permanently reshaped human civilization. It created the blueprint for every empire that followed, such as Assyria, Babylon, Persia, and even Rome. It introduced ideas like territorial states, imperial governors, divine kinship, and the idea of empire itself. These ideas inspired later prosperous periods and tyrannical dictators, a cycle that has continued well into the modern day. Of course, other continents like the Americas came up with their own empires completely independently, but it's still important to look at the origin of empire. History would march on from Akkad in terrifying directions. Empire after empire would violently rise while most quietly fell. The world would become more and more interconnected with global trade, colonization, and conquest. Humans would go on to create empires which spanned the globe, developing terrifying technology along the way. Warfare would plague every century, and as technology improved, it only got more devastating. Culminating in 20th century technology, now with the press of a single button, entire empires could fall, kept at so-called peace only by the promise of mutually assured destruction, leading to an uncertain world. And this is where we will leave off. We had a long and storied history that is criminally unknown by the average person. I was only able to cover so many areas and periods in detail, so I apologize for the intense focus on Western Asia. And I had to speed up the end there because I'm honestly just not really interested in these later periods of history. But I hope this project really transformed your understanding of the Stone Age and the development of human civilization. However, I'm working on a video that covers the entire world 5,000 years ago. It looks at every region on Earth, exploring the bountiful cultures of the time. So be on the lookout for that. This has been your host, North02, and we'll see you in the next one. Arrivederci.